10.2? Okay, so we're talking about vectors in calculus now, and we're not going into some deep discussion of vectors here. That's in physics. We're just going to talk about the calculus involved. Okay, so just review. X prime of t is the same as dx dt, right? And what does that represent?
The change in the x direction.
The rate of change in the x direction with respect to t, right? Okay, so that is rate of change in x coordinate with respect to t. What else does it symbolize? Yes, very good. That would be the velocity of the particle where?
At time to be in the x direction.
In the x direction, right? Or in the horizontal direction. Because we said this yesterday. Vectors are made up of two components, right? A horizontal component and a vertical component. And then its resultant vector has both a speed, right, and a magnitude, direction and magnitude, or speed and magnitude. That is with direction. Okay, and then similarly, y prime of t, we're basically just repeating another symbol for it would be dy dt. By the way, the dx dt and the dy dt look very much like parametric, right? Okay, and oftentimes on the free response questions, you'll be asked a vector and a parametric question about the same problem, okay? So this would be the rate of change in the y coordinate with respect to t. It's the velocity of the particle in what? Yep.
Y direction.
In the vertical or y direction. Okay, so let's talk about vector notation in calculus. So the only thing that differentiates the vector from a parametric is the little brackets here. And again, a lot of times they're used interchangeably in your calculus free response questions. So you might see parentheses around them, when you're dealing with parametric. Those little brackets, though, indicate that you're talking about a vector quantity. And this would represent the position vector. At time t. And then if you're asked for a velocity vector, do you have any thoughts on what you might do there?
Changing y over changing x.
X prime of t and y prime of t would be your velocity vector. So it differs from parametric in that regard. Okay, so like in parametric, a lot of times you're going to be asked for the derivative of y with respect to x. Okay, in which case we're going to do what we did yesterday, right? Dy dx would be dy dt over dx dt. If you are simply asked for a velocity vector, you're going to list them separately, x prime of t and y prime of t. Yes?
Are we ever gonna see like dx dt, comma dy dt like that in vector notation?
You might. But it'll probably be more like this. Okay, you'll start to see, like, whenever we start looking at some sample AP problems where they're kind of mixed together. Okay, so this represents the velocity vector. At time t. And then you might also be asked for the acceleration vector, in which case you're going to just do what?
X double prime of t.
Yes, x double prime of t, y double prime of t. Okay, so when we talk about vectors, those of you, in physics, and I guess you even cover this in Physics 1. I'm not really sure. It's been a very long time since I've been in physics. Do you talk about vectors? Like, do you draw
I
them?
was like the first.
Okay, so like this arrow right here would be labeled what? dx dt, right? And then the whole tip to tail thing, right? So I do this and this component here with our arrow on it. We're indicating we're movement. This would be labeled dy dt. And then, do I draw my resultant this way? That's what I thought.
Yeah.
Okay, and so this is your resultant vector. So how do you calculate the resultant vector?
Pythagorean theorem.
Oh, yeah, fine.
Say again?
Pythagorean theorem.
Yeah, the Pythagorean theorem, right? Okay, the Pythagorean theorem. And what would that give me? Okay, but what does it give me in life?
Where it's actually going.
What does it mean?
The velocity.
No, not distance traveled. The speed, right? Or velocity, I guess. The speed of it, right? So your speed would be the square root of dx dt squared plus dy dt squared. And it has to be calculated at some value of t. Okay?
That's exactly like.
It's not arc length because we're not summing it together, right? Okay? So this is simply Pythagorean theorem. But because these are rates right here, right? Because these are rates and you're doing Pythagorean theorem on rates, this will also be a rate. Okay? So must be computed at a specific time. T. So in other words, it would ask you, like, what is the speed at time 2? Okay, so you're going to have to figure out the horizontal component at 2, the vertical component at 2, and then calculate its speed. All right, so how are you going to calculate the distance traveled?
Integrated?
Integrate it. Why would I integrate it, Ted?
Because that's the velocity and you want to.
Very good, because this is velocity, right? Okay. So if I want distance traveled, by the particle from t equals a to t equals b. Yesterday I used t1 and t2, but today I'm calling them a and b. Tell me what I write. Integral from
A to B.
a to b.
Square root
dx dt squared
Yep.
plus dy dt squared.
So that looks exactly like what?
Arc
The arc length of a parametric, right? And that's why the problems get all mixed together.
It's pretty simple.
All right, so I'm going to give you this handout, and this is where our examples are going to be. The examples would take a while to write, so I've typed them for you.
This is a vector.
I'm being consumed by which I was born.
Connie got it.
Oh, yeah.
All right, ready? Particle moves in the xy plane so that any time t, the position of the particle is given by x of t, y of t. So at that point right there, that could be parametric, could be vector quantity, right? Either way, you've just been given an x and a y that's in terms of t. Now part A though says, find the velocity vector when t is equal to 1. You've been asked for the velocity vector, so what are you going to need to do?
Find the result.
Calculate the derivatives separately, right? I'm not going to do a dy dx kind of thing. I'm going to do x prime of t, and then I'm going to plug in 1, and I'm going to do y prime of t, and I'm going to plug in 1. If you are ever asked for a vector quantity, you're going to keep those two pieces separate from one another. Okay, I'm not going to combine them at all. All right, so for my velocity vector, x prime of t is equal to what?
3t squared.
3t squared plus 8t. And then I want to figure out that at t equals 1, so what's that equal? 11. And now I need y prime of t, which is 4t cubed minus 3t squared. And I also need to calculate that at 1, which is 1. So my my velocity vector at t equals 1 is 11, 1. You could leave it just like this, just so you know, like if you're taking the AP test, you don't have to go over here and write it in this fancy little vector form. Okay, you can leave them just like this. Okay, now I want the acceleration vector, right? I'm not being asked for a second derivative of a parametric here. I'm being asked for an acceleration vector. So what am I going to need to do?
Differentiate.
Differentiate the x.
Yep, differentiate the x, and what will you get? 6t plus 8. And then I need that at,
2, which is 20. 2, right?
yes, at 2, which is 20. And then I need y double prime of t, which is
12t squared.
12t squared minus 6t. And I need that at 2, which is 48
36.
minus 12, which is 36. So your acceleration vector is 2036. Hey, go back over here, guys, on this picture where we put resultant vector. You can say that that's the magnitude as well. I think I said it, but I didn't write it. You need a picture to go with it.
Got the full t minus 13.
All right, example 2. A particle moves in the xy plane so that any time t greater than or equal to 0, the position of the particle is given by x of t and y of t. Find the magnitude of the velocity vector when t is equal to 1. I want the magnitude of the velocity vector when t is equal to 1.
So now are we finding
We have
like
to
the
find
resultant
dy.
kind of thing?
Yes, so now I'm finding the resultant. But notice you've been given the what?
The position.
I've been given the position.
So you have to find
Right?
the
I want the
velocity.
magnitude, so I'm gonna have to find the velocity equations of those things before I go and address the magnitude, right? Okay, so let's find x prime of t. And what is it? 2t plus 3. And I need that, I need this calculated when? At 1. So at 1 I get 5. And I also need y prime of t, which is
3t squared.
3t squared minus 6t.
Negative 3.
And I need y prime of 1, which is negative 3.
Your magnitude or your speed in this case.
Right, magnitude, speed. It would be the equivalent of speed since it's always positive, right? Okay, but my magnitude is equal to that resultant vector.
Square root.
So it's square root of 5 squared plus negative 3 squared, which is the square root of 34.
34. So that's
Any questions? We doing okay? Hopefully it seems easy.
Yeah.
I mean, everything pretty much seems easy after series, I think, but. Okay, a particle moves in the xy plane so that x is equal to square root of 3 minus 4 cosine t and y equals 1 minus 2 sine t, where t is between 0 and 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the two intercepts. Do not evaluate. Okay, so let's think about what we're being asked. Ultimately, we're being asked to calculate a what? A distance, right? A distance traveled, okay? So I'm going to have to do what in order to do that?
great.
I'm going to have to integrate, right? Okay, because that's how I get my distance traveled. But I need to integrate where?
Between
Between the two
x-intercepts.
x-intercepts,
So you have to find
right?
when y equals 0.
Yes, so I have to figure out when y is equal to
0.
0, right? That's how I
That's
find
your
x-intercepts.
limit of
Yep, and those are going to be my limits of integration, right? So remember here I'll put to find x-intercepts, let y equal 0. So that means that 1 minus 2 sine t, because that's y, that's what I want to set equal to 0. So I'll get 2 sine t equals 1, sine t equals 1/2.
Pi 6 and 11 pi 6.
Yeah, so here you were given, unlike number 10 in the homework, right, where you weren't given an interval to work on. I have an interval. It's from 0 to 2 pi. And sine is 1/2 at pi 6 and
11 pi 6.
it'd be negative there. It'd be 5 pi 6, I think. Right? Because in the quadrant 4, yeah.
5 pi 6.
Okay. So that's going to be at pi 6 and 5 pi 6. Okay, so we talked about this a minute ago. My distance traveled, or, in this particular case, my, no, never mind. Distance traveled is going to be equal to the integral from where to where? Pi 6 to 5 pi 6 of the square root of And then remember, I'm going to insert this step. You don't have to if you don't want to, but I'm going to put it in so that you remember what it is that we're doing. I have to integrate the velocity, right? Okay, in order to get distance traveled.
Should be 4 cosine or 4 sine.
Yeah, so my dx dt, the square root of 3, that derivative is just 0. And then the derivative of negative 4 cosine t would be
4 sine t
4 sine t,
squared.
right? Plus dy dt will be equal to negative 2 cosine t squared dt. And now you need your calculator. Or actually, it says do not evaluate, so you're finished. Okay. So that's a non-calculator question, by the way, is instead of them actually asking you to evaluate the integral, all they want you to do is set it up. Okay. So, you know, the part about this particular section that's sort of easy is it's not, you know, it's just calculating derivatives basically, but if you're not a good formula person, you know, at keeping formulas straight in your head, that may be where you have some difficulty. By the way, you can mark through this example, the bottom example, it's the same one we just did. Okay, so this is an old AP question, an old AP free response question. Hopefully after you do it, you're like, I hope I get a lot of those because that seems really easy.
This is like
Okay, so here we go. An object moving along a curve in the xy plane has position x of t, y of t at time t, with dx dt equaling that, dy dt equaling that. At time 2, the object is at the position 1, 4. Okay, so it looks a little bit like the problem yesterday, right? Okay, that we did together. But notice A says, find the acceleration vector for the particle at t equals 2. It doesn't say find the second derivative, right, dy dx. It says the acceleration vector. As soon as you see those words vector, you're going to do what with those two quantities? Keep them separate, right? Keep them separate whenever you, when you differentiate them. Okay, so let's find x double prime of t. I'm just going to relabel it that. And say that again. Right, it's right there. But it wants the acceleration vector? Yeah. Okay.
cosine t cubed.
So, what is the derivative of sine t cubed?
T squared, t squared.
Divide.
Yep, because it's cosine of t cubed times the derivative of t cubed, right?
Oh, yes.
Using the chain rule. And then my y double prime at t, right? This is like your peanut M&M thing. So the derivative of cosine is negative sine t squared, but then you have to multiply that by 2t, right? And notice they told you when they wanted the acceleration vector. So what do you have to do now? I have to plug in 2, right? So you're going to get 12 cosine 8. And even though this is a calculator question, you could leave it exactly like that, and I would. And then y double prime at 2 is negative 4 sine 4.
You have to plug it into your calculator.
Yeah, so you can either plug those into your calculator and write the decimal approximations, or you leave them exactly like that. Yes, you do not have to do that at all, because this is an exact answer. It's better than the calculator approximation anyway. Okay, part B, write the equation of the line tangent to the curve at the point where t is equal to 2.
Now we need the actual.
Okay, so I want an equation of a tangent line at the point where t is equal to 2.
So dy dx now.
Yes, okay, so here's what we need to think about. In order to write an equation of a tangent line to a curve, I need a point and I need the slope at that point. Do I have the point at time 2? Yes, it is 1, 4. These are what kind of coordinates? They are whatever somebody said, that is position, but they're x and y, right? They are x and y coordinates. So going back to what Vinny said, if I want to write an equation of a tangent line to a curve at this point that is defined as 1, 4, that's an xy, I now need dy dx. Are you with me? Okay, so remember I just said a while ago how parametrics and vectors get combined into one problem? Here you go. Okay, so my point is 1, 4, and now I need the slope. Oops, at t equals 2. Right, so there's my point at 2, I need my slope at 2. So to get dy dx, I need to do dy dt over dx dt at t equals 2. Well, what were you given? Dy dt and dx dt. So you should get cosine of, okay, and we're at t equals 2, so cosine 4 over sine of 8. So do you have everything you need now in order to write an equation of a tangent line? Yes, you do. So tell me what to write. Y minus 4 is equal to cosine 4 over sine 8. Yep, x minus 1. And that's your equation of your tangent line. No, you can't simplify the arguments. You can't reduce those because the order of operations says you have to do the trig function first. Okay, what have we switched back to in part C? Vector, right? We've gone back to more of a vector question. I want the speed of the vector at time 2. Okay, so the speed is equal to what? The square root of,
Sine t cubed squared.
and this is what I'm going to do just to show the step. I'm going to do dx dt at 2 squared, and you don't have to write this in. I'm just showing you what's really happening. Plus dy dt at t equals 2 squared. Right? That's really what the speed is. So that is equal to dx dt at 2 was, right? So I have sine of 8 quantity squared plus dy dt was cosine 4 squared, and that is the speed. And
1.186.
okay, you could leave it like that, just so you know, okay, because that would be an exact answer, or you can calculate it. Okay, and so talk at your table about how you're going to do letter D.
Yeah, as a legal condition, integrate both the x and the y.
Oh.
Yeah, like separately.
Because like on the last one, I couldn't find out where x is here.
So,
It would just be negative 15.
so You just have to keep the X and Y separate.
So
Integrate dx and t.
you mean T4 I didn't know you were saying just have one.
Like this one, like the t equals 2 is yeah, you subtract Sure.
Because if you're down to you just
If you're stuck, think fundamental theorem of calculus. Yeah.
That time into this position that gives you the vote.
Know anything about
That's the exact, you don't be able to. So, which one's square?
why I said think fundamental theorem.
Because 4 is what you had.
1.
One to two.
That would be the derivative of what is attracting one
That's what got
it.
Oh, is it over t?
So 4 minus
So like the way to think about it would be, so when you integrate, right, in fundamental theorem, when you integrate from A to B, that's the same as capital F of B minus capital F of
there's like a 1 over
A, right? So it's like you're doing that, integrating from 1 to 2, and that would be the same as x of 2 minus x of 1. Yeah. Okay, so a while back, did you wanna?
I think
Okay.
you say it and I'll.
No, go ahead if you wanna go.
Does it have to do with we did some integral and we set it equal to f of b minus f of a?
Yeah, that's exactly what I said, try to think fundamental theorem of calculus, okay? So if you remember, a while back, we came across some problems that we were not able to integrate by hand, and we had to use fundamental theorem to help get us to our answer. And we also had to do that because we didn't know the starting point. Okay, so in this particular problem, you're asked to find the position of the particle at time 1. Well, the only way you can do that is by starting with some other position that you know. So if you think about the one we did yesterday, The one we did yesterday was a little easier because you went from, it was from 2 to 3. You started at the point that you knew, and you're working backwards in this particular problem. So you know the position at time 2, okay? So here's what you know. You know that if you integrate from 1 to 2, and you integrate x prime of t dt, by definition, what will that equal? X of 2 minus x of 1, right? What are you interested in? X of 1, right? X of 1 is what you're interested in. That's the x coordinate at time 1. You know the x coordinate at time 2. What is it? 1. And can you calculate this? Yeah, because it's a calculator question. Okay? So I go the integral from 1 to 2 of sine t cubed dt, I know will be equal to 1 minus x of 1.
That's by the I don't know if I got the right answer.
Right? So you can move this over here if you want. X of 1 will be equal to 1 minus the integral from 1 to 2 of sine of t cubed dt. And some of you might have been able to go directly to this step right here without thinking through the fundamental theorem, but I want to show you guys that maybe couldn't, that that's what's happening. Okay?
What's the answer?
Um,
Oh, you need to come.
yeah, you have to have a calculator. I got 0.782.
No, you just for the y.
Yeah, so now I have to do the same thing for the y coordinate, right? This only gave me the x piece of it. So again, I'm going to follow the same kind of work I did here. If you were able to go directly to this step, no problem. But basically what I know is if I integrate y prime of t dt from 1 to 2, that would give me y of 2 minus y of 1. So if I integrate from 1 to 2 cosine t squared, y of 2 was 4 minus y of 1. So the position at 1 will be equal to 4 minus the integral from 1 to 2 of cosine t squared dt.
What'd you get from that?
Yeah, that's what I got. Okay, does that make sense, everyone? These are great AP questions because there's so much there, but do you see what I meant by going back and forth between some like parametric and some vector and how it's all in the same problem? Okay, so you have, well, you just have a few minutes, but what I want for you to do tonight,
That's kind of good though. We don't have a longer time.
we're going to do the first worksheet, worksheet 1. So we're going to do 1 through 13. Some of those should go pretty fast.
Yeah, we're just saying.